Hey everybody, welcome back. This is part 2, and in this video what we're going to do is the selection process for genetic algorithms. Now, last time we created 100 potential backpacks where the one indicated that we're going to take some item and put it into that backpack, and we had our weights and our cost and everything like that. So we had a bunch of items, each had a different weight and the cost associated with it, and we fill these backpacks in. What we noticed was that we had a lot of backpacks that were probably overloaded. And by overloaded, I mean they're exceeding the weight of 15 kilograms. So like this one here is definitely going to be over. We've got 2, 3, 7, and 5. That puts it at 17, which is over. While other backpacks were like this one, where it only had a single item in it, which was 3, which means it can take a lot more stuff. So what I'm going to do is first I'm going to comment out this, and we're going to make the selection process where we take out all the backpacks that are invalid, meaning that are over 15 kilos first. So I'm going to say backpacks is equal to selection, and this function is going to go ahead and it's going to take in our backpacks, it's going to take in our weights, it's going to take in our costs, and it's going to take in the max weight. All right. So I'm going to scroll up here. I'm going to make that function, and backpacks, weights, cost, and max weight. And the first thing we're going to do is we're going to get rid of all the overweight backpacks. So to do that, I need to create a list first, which is going to store all the new valid backpacks that we can use. And I'm going to say for backpack in backpacks. I'm going to get one backpack out after another, and I'm going to make another function here that's going to help us, and I'll make it out here first, and that function is going to be called getWeight. Now, in order to get the weight for an individual backpack, we have to loop through that individual backpack, and anywhere there's a 1, we're going to need to add up the corresponding index in weights. So we're going to pass in one backpack to get weight, so this backpack that's coming out through this loop, and we're going to pass in weights. And if that particular backpack is less than or equal to our max weight, then we're going to put it inside as our valid backpacks list. Okay. So let me just walk through this one more time. So for every backpack in backpacks, we're going to pull out one at a time. We're going to check that it is under 15 or equal to 15 kilos, and then we're going to put it in this valid backpacks list. So the only thing we need now is this getWeight function. So let's use make a function called getWeight. That's going to take one backpack and the weights, and I'm going to make a initial weight variable equal to 0, and then I'm going to loop through all the length of backpack. And so as I loop through the length of this backpack, I want to check if that particular backpack, if that particular backpack at that index is equal to 1, I want to get the corresponding index in weights and add it on to my weight total. And I'll return the last weight. Okay. So let's just go ahead. I'm going to comment this out right now. And what I'm going to do is I am going to run this for an example weight. So I'm going to say print single backpack, which I'll just get the first backpack in our backpacks list. And then I'm going to print get weight for that same backpack. And let's run this. So in this case, I've got the first backpack in my backpacks, which is 111. So that is the weights of 2, 3, and 7, and if I add all of those up, I should get 12. So the getWeight function actually works. If I run this again, I'll get something different. So 5, 6, 2, 3, that's 16, and works just fine. All right, so getWeights is working, and I can get rid of this. No longer need that. And let's go ahead and loop through all of our backpacks. So all this is doing is just checking, is the backpack under the correct weight or not? What's going to happen is if I print out the length, now we know for a fact that this is 100 to begin with. So if I print out the length of these valid backpacks here, I get 44 in this case. And if I run it a few more times, it's always going to be somewhere around 40 to 50s usually. So we're actually losing about half of the backpacks every time we do this. And that kind of makes sense when you look at the weights down here, because if you pick any 3 of these weights at random, it's pretty likely that you are going to get close to 15 kilos. And some of them, if you pick 3, you're going to get over 15 kilos, like 7 and 9 and 6, or even 7, 9 and 5. 7 and 9 just by themselves is going to be over 15. So any of these in here, you pick 3 of them, you have a fair shot of kind of going overweight. 4, definitely you're going to be overweight. So that's kind of why we're getting less than 50 here most of the time in the 40s, sometimes in the 50s. All right, so that kind of clears out the backpacks by weight. Now, the next thing we have to do is we have to figure out which one of these backpacks are actually going to be the best backpack. So we also want to calculate the fitness values. So the fitness values in this case are the total cost of the items in the individual backpack. So I'm going to do that by fitness values.append. I'm going to make another function called getCost, and getCost is going to take the individual backpack in and all of our costs. So it's actually going to be almost identical to getWeight, except that instead of summing up the weight for that particular backpack, it's going to sum up the cost. And it's actually really easy. All I really need to do is I just need to copy this. And what I can do is I can just say weights. I can replace that with cost. And I can say weight, and I can replace that with cost. And I don't know what happened with that. There we go, return cost. Okay, so that's all I had to do was just replace this. And now if I walk through this, I initialize the cost to 0. I loop through all of the individual items in this particular backpack. If it's a 1, I'm taking that item. If 0, it's not. If that item is a 1, I need to add up the cost for that item, and I continue until I've gone through all the items in the backpack, and I return the cost, and I append it to this fitness value list. So this is the fitness value. Higher cost, better the backpack. So before I end this video, let's just go ahead and see what this looks like. So let's, if I run this, it should work just fine. And now let's print them all out. So I'm going to say for I in range, length of backpacks, and I'm going to print out, so backpack, let's do it like this, backpack, backpack I, and let's see, it's going to be backpacks I, and then I need to do ways, or so costs, and then we'll do fitness value of I. Okay, oops, what did I do wrong here? Get weight, backpack cost. Oh, sorry, this should be valid backpacks. Let me go back here, it's valid backpacks. All right, good. So if I run this, what we get is we have 42 backpacks, a very auspicious number, and we have a list of the cost as well. So these are all of our backpacks, and we notice that we've got some that are quite high, cost of 16, and we've got some that are cost of 0. Probably don't want to bring those on with us to the next stage, but we'll see. So how do we know which of these backpacks that we want to carry on to the next stage to reproduce? Well, we're going to do that in the next video. We're going to talk about some things called like like a triangular distribution and how we can use that to randomly kind of pick the best ones or give those good ones an advantage. All right, so in the next video, we'll talk about that. And if you have any questions, leave them in the comments below. Thanks.